to Lesson 4 of Math 7 with the Alberta Curriculum Tutor. Today, we will be covering the basics of exponents. Okay, in order to understand the basics of exponents, we need to look at the different ways numbers can be written. So, when talking about exponents, we talk about three forms of writing numbers. So this first form, which probably looks quite unfamiliar to you, is known as exponential form. Now, right now, this probably doesn't make a lot of sense, but as we go further into the lesson, it should make more sense. This second form, where you basically have one number written as a when you have a multiplication statement basically written out, is known as expanded form. And this last form is known as standard form. And this is basically just what regular numbers look like and what you've seen so far. Okay, so for the first thing to learn about exponential form, we're just going to look at the parts of this figure. So this figure actually, this whole thing is known as a power. This 5 right here is known as the base. And this 3, which is written in the top right corner of the base, is known as the exponent. So, you might be wondering how we would say this. So, if we were trying to read this aloud, how would we read this aloud? So really, how it reads out is 5 to the power of 3. So basically you say whatever the base is, so in this case 5, to the power of whatever the exponent is. Okay, so let's take a look at these two powers. So we know we can say this is 5 to the power of 2, and this can be 5 to the power of 3. But when our exponents are 2 and 3, there are special ways of saying them. So when the exponent is 2, you can say that the number is squared, or the base is squared. So in this case, the base is 5. So you could also say that this is 5 squared. So basically, we say the base, and because the exponent is 2, instead of saying to the power of 2, we can just say squared. Now, for this one, the base is also 5, but when something is to the power of 3, or the exponent is 3, you can say that the number, the base, is cubed. So 5 to the power of 3 is the same as saying 5 cubed. Okay, so numbers written in exponential form can be converted to standard form. This is often known as solving or simplifying. So in order to understand how we're going to solve powers such as 5 to the power of 3 or 5 cubed, we need to understand what this means. What does 5 to the power of 3 mean? So, basically, how an exponent works is that you take the base, which in this case is 5, and you multiply the base by itself the number of times that the exponent tells you to. So in this case, the exponent is 3. So what we're going to do is we're going to multiply 5 times itself 3 times. 5 times 5 times 5. And here you notice we have the expanded form that I talked about earlier. And you see we have 3 5s, 1, 2, 3. And 5 times 5 times 5 is equal to 125. And therefore we say that 5 cubed, or 5 to the power of 3, equals 125. Let's do another one. I'm going to go 3 squared, or 3 to the power of 2. So, what does this mean? Well, we have the base 3, so it's going to be 3 times, how many times are we going to times 3 by itself? Well, the exponent is 2, so the answer is 3 times 3. We have 2 3's in our expanded form of the multiplication statement. And that equals 9. Before we move on, I would like to address a common mistake that many people make. And when they see 5 to the power of 2, automatically they accidentally do 5 times 2. This is not the same thing. These are not equal. They're very different things, because 5 times 2 equals 10. And as we discussed, if we had 5 squared, we're going to take the base, and we're going to times the base by itself twice, because the exponent is 2, so 5 times 5, that equals 25. As you can see, 25 does not equal 10. So it is very important when solving these powers that you don't accidentally multiply the base by its exponent. Now we are going to discuss certain powers. Here I've just used x to mean any number. So we'll do an example. So when we have 1 to the power of anything, so let's choose a number, let's say 1 to the power of 5. 1 to the power of anything always equals 1. And the reason for this is because if we had 1 to the power of 5, it just is 1 times 1 times 1 times 1 times 1. And 1 times 1 times 1 times 1 times 1 is going to equal 1. Now, if we have any number to the power of 1, let's choose a number. Let's say 5. Let's go with 5 again. 5 to the power of 1 is equal to 5. And why is this? Because the base is only multiplied by itself once. So the expanded form is simply 5. That's it. Now, x to the power of 0. Let's go 5 to the power of 0. So anytime any base is to the power of 0, the answer is always 1. And at first, this is going to seem a bit weird. 5 to the power of 0 equals 1. And don't try and write this in expanded form. It's not going to work exactly here. But in the next video, I will be exploring why any number to the power of 0 is equal to 1. And 0 to the power of any number, so 0 to the power of 5, that's just going to equal 0. Why? Because in expanded form, it's 0 times 0 times 0 times 0 times 0. Because you have the base 0 times itself 5 times, which is the exponent, and 0 times 0 times 0 times 0 times 0 is just going to equal 0. Congratulations on finishing Lesson 4 of Math 7 with the Alberta Curriculum Tutor. So here we have an overview of what we covered, and it is a lot that we covered today. So just to recap, we talked about the parts of an exponent, the different forms that numbers could be written in, how to say an exponent out loud, and then little tricks for doing exponents.